Good morning, class. Mr. Pulaski here. Hope you're having a good start to your day. I'm recording this the day before, but it should be morning for you guys if you guys started out your day right and got right to work. But yeah, so we are doing 10.2 today. This whole chapter is about circles and like parts of circles with secants and chords and tangents, which we learned about yesterday or the 2 days ago in 10.1. And we are learning about arc measures today. So let's go ahead and read the name of the lesson and the essential question. Name of the lesson. Ready? 1, 2, 3. Find arc measures. Essential question. Ready? 1, 2, 3. How do we use angle measures to find arc measures? Okay, so arcs of a circle are basically just part of a circle, okay? So if we have a circle like this, and we have this part right here, this would be an arc, okay? It's just part of the circle, all right? That's kind of all we're talking about today. So hopefully this stuff makes sense, and yeah, let's go ahead and get into it. So we have some definitions to fill out first. I'm going to draw some pictures for you guys, too, to make sure you guys know what we're talking about here. So we have central angle. A central angle is an angle whose vertex, whose what? Vertex is the center of the circle. Okay, so, and I don't know if you guys remember this, but we did, like, theta, which was like that. That was really bad. I'm sorry. I'm a little embarrassed. That's theta. That's a Greek symbol, okay? So if we draw a circle over here, that wasn't too bad. So we're going to draw here's the center of the circle. We're going to draw an arc, an angle. So there's an angle. This would be theta right down here. And this is A and B. Okay? So that's a central angle, and that's an angle theta that is in the middle. It meets in the middle of the circle. The vertex is in the center of the circle. Okay? Then we can put C over here, actually. Let's put C over here. Okay? So, yeah. So that is a arc. An arc right here would be like this section right here. That is an arc. All right? Okay, so a minor arc. A minor arc is part of a circle measuring less than 180 degrees. Measuring what? Less than 180 degrees. So in this case, the arc that would be less than 180 degrees would be like this. It would be AB. We put the little arc above it to show that's an arc we're talking about. Okay, so AB right here, doesn't this look like it's less than 180 degrees? 180 degrees is how big of a circle? 180 degrees is half a circle. Does this look like it's half a circle or less than half a circle? Yeah, it looks like it's less than half a circle, so that's going to be good. And then a major arc. A major arc is part of a circle measuring between 180 degrees, between what? And 360 degrees, and what? So, for example, measuring between 180 and 360 would be, for example, all the way around over here. I'm going to use a different color so you guys can see this better. Sorry if I was being confusing. So, right here, I'm going to erase these two. We're going to take our time, make sure we do a good job with this, make sure you guys feel good, okay? Okay, so for example, so in an arc ACB, that's going to be between 360 and 180 degrees. Okay, it's almost all the circle except for this pink part right here, right? So that's going to be a major arc. So a minor arc is less than 180 degrees, and a major arc, so the minor arc was over here, and the major arc was all the way around over here. Okay? And, yeah, so here we go. Cool. And then we're going to talk about a semicircle, an arc with endpoints that are the endpoints of a diameter of a what? Of a diameter, which is going to equal 180 degrees. So over here, I'm going to draw a circle. And we're going to draw a semicircle, so it's going to go like this. That was bad. Let me fix that. Let me draw a center of the circle first, and then draw a line through it. There we go. Let's use a different color. Let's use orange. So this would be a semicircle. Okay, just checking my notes here. Okay. So the semicircle is in orange. Major arc is in green. Minor arc is in pink. Okay? All right, so hopefully that makes sense. It's basically just parts of the circle. We're breaking down different parts of the circle. So the measure of a minor arc, let's use a new color here, is going to be the measure of its central angle of its what? Central angle. Okay, so basically where the angle meets in the center of the circle, that's going to be the measure of the minor arc. It's always named with two letters. So for example, the measure of a minor arc is going to be measure with the little m like we do with angles of AB. It's only going to use two letters because it usually only goes, two letters usually means it's a smaller arc, whereas three letters, like with the green one, went all the way around over here. This is three letters like ACB. But for a smaller arc, it's going to be two letters like this. Okay, so this is the measure of minor arc is measure of AB like that. And then the measure of a major arc, so a minor arc is less than 180 degrees, major arcs are bigger. So the measure of a major arc is going to be the difference between 360, let's use a different color again, between 360 degrees and the measure of the related minor arc. Okay? Always named with three letters. That's going to be measure of you can do ABC or ACB. I'm going to do ACB because usually if we do the minor arc is like the two letters, then we go the other way around. If the two letters are right here, we go all the other way around. You could have also done BCA. That also would have worked. Okay? So that's the measure of arc, major arc, ACB. Okay. All right, and then congruent circles are circles that have the same radius. The same what? Same radius. And congruent arcs are arcs that have the same measure. The same what? And they're the arcs of the same circle or of congruent circles. Okay, so hopefully this is making sense. Got a lot of different colors happening here and stuff, and it'll make more sense once we get into some actual problems here, okay? All right, so let's use this one. Okay, so measuring arcs. The measure of a minor arc is the measure of its central angle, and the expression measure of angle AB, like the arc AB, is read as the measure of arc AB, like we talked about. The measure of the entire circle. How many degrees is an entire circle? Yeah, it's going to be 360. So the measure of a major arc is the difference between 360 and the measure of the related minor arc. And the measure of the semicircle is going to be 180, like we talked about. Okay, so do you see how right here, this is, let me zoom in really far here. See how this is 50 degrees? This is a 50-degree arc. Okay, if this is 50 degrees, what's the rest of it going to be? What's the rest of this going to be? How would you find that? Well, a whole circle is 360, right? And then we're taking away the 50. What's 360 minus 50? Yeah, it's going to be 310. That's where they get the 310 from. It's kind of like, you remember the, if you had a line where this was 7 and this whole thing was 12, how would you find x? Well, you do x is going to equal 12 minus 7. It's kind of the same thing, except now we're doing like arc measures on the circle, okay? So if this part is 50, if this is 50, the rest of it's going to be 360 minus 50, okay? Hopefully that makes good sense. Let's go into an actual example here, okay? So we have, find the measure of each arc of circle C where DF is the diameter. Okay, we're looking for the measure of arc of DE. Measure of arc of DE. Well, DE is right here. And remember, the measure of an arc is going to be equal to the measure of its central angle. What's the measure of the central angle there for DE? Yeah, hopefully that was pretty quick and easy. So measure of DE is going to equal the central angle, which is 117. It's 117 degrees. Use a different color now. And then we're looking for the measure of major arc DFE. So another thing you want to do when you're labeling these, like when you're going through these arcs, you want to go exactly like it says. So it says D, F, E. So we're going to go like that. We're going to go the exact direction it says. We're going to go D to F to E. So that's the rest of the circle. So if the rest of the circle's in red, and the rest of it, and the part that we don't want is in blue, how do we find the measure of arc DFE? Yeah, what we're going to do is we're going to do 360. The whole thing is 360. We're going to take away 117. That will be the rest of the circle, which is in red. So that's going to be, so measure of DFE is going to equal, that's going to be 243 degrees. Guess we could box our answers like we usually do. That was embarrassing. Okay. And then the next question they're asking, let's use green, is they're looking for a measure of arc DEF. So we're going to follow exactly like it says. We're going to go to D to E to F. We're going to go around the outside like this. Well, it said that DF is a diameter, which makes this a what? That's half the circle, which is going to equal how many degrees? Yep, half a circle is 180 because the entire circle is 360. So remember, if this is a diameter right here, if this is a diameter, that means it's a semicircle. Each half is a semicircle, which means it's going to be 180 degrees. Okay? All right, we have. I'll leave this right where pause where it is. You guys can go ahead and try checkpoint 1 on your own. Go ahead and pause the video. All right, welcome back. So for this one, well, we're looking for RTS. We're looking for RTS, which is all the way around like this. We're looking for RTS, okay, which is the rest of the circle. We know that this part of the circle is going to be 45, right? So if we're looking for everything outside of 45, we're going to do measure of major arc RTS is going to equal, well, we're going to do 360 minus 45, which equals 315 degrees. So that's the part of the rest of the circle is going to be 315 degrees. Okay? All right. Now, let's use black. Arc addition postulate. Do you guys remember segment addition postulate a while ago? So basically, if we have a segment, this is X, this is Y, and then this whole thing was Z. What was the equation for that entire thing? Hopefully you remember it's going to be X plus Y equals Z. The two parts, this part and this part is going to equal the entire thing, which is Z. Same kind of thing here. If we have, let's see here. So if we have measure of ABC, this entire arc right here. Let's make that a little bit nicer. This entire arc right here, go around the outside. That entire arc is going to equal, if that entire arc has two arcs inside of it, it has AB, it has this part, and it also has this part right here. This is kind of sloppy, but hopefully it makes sense. So what we're going to do is just like angle addition postulate. We have two arcs inside of this big arc. So measure of of arc ABC is going to be measure of minor arc AB plus minor arc BC. Okay? So it's just like the segment addition postulate where you add the two parts to make the whole. Same thing here. We have this part and we have this entire part over here, which means it's going to add up. Those add together are going to equal the entire major arc, which is ABC. Okay? All right. Let's do one together, and you guys will try one on your own. Which one should we do? All right. Well, we'll do example A together here. All right. So we're looking for measure of arc BD. Well, BD goes all the way around like this, and you see it has C within it. Actually, wait. It's a minor arc, though. So this would actually be, okay, so remember that major arcs are bigger than 180 degrees. Does this that I just highlighted, does that look like it's bigger than 180 degrees or less than 180 degrees? You should have said it's bigger. Do you see how it's bigger than half a circle? Like half a circle would continue like this. This would be half a circle right here, right? So I actually did this the wrong way. Hopefully you guys caught that. If you didn't, that's okay. But I goofed up here. So measure of arc AB is going to be, it's going to be this to here. Okay, remember, three letters means it has to go the long way around the circle. 2 letters means it's the short way. Okay, so we have that entire arc right there. We have this part of the arc as part of it, and we have this part of the arc as part of it. Okay, so we know that so measure of, so the 2 parts of arc BD, which is all the way around here, is going to be, what two arcs are part of that? Hopefully you said measure of arc BA plus measure of, arc AD. Okay, those are the 2 smaller arcs that make up that entire big arc. So what is the measure of arc BA? Well, it says checking right here. It says right here is 55, so that's going to be 55 plus, and then over here we have the savings is 105. So that means that our arc, the entire red one over here, measure of arc BD is going to equal, what's 55 plus 105? Yep, should be 160. And is that less than 180 degrees? It is, and that should be correct. Okay? If it's less, because this is two letters, which means it needs to be less than 180 degrees. That's a minor arc. Okay, why don't you guys pause the video and do checkpoint, or example 2 on your own with BCD. Okay, so for this one, we should have had measure of, I keep want to do angles here. So we're doing measure of BCD. BCD, so it should be measure of arc BC plus measure of arc CD, which would be what, 140 plus 60, which would equal 200. So measure of BCD equals 200 degrees. And is that bigger than 180 degrees? Yep, so that means it's a major arc, which is correct. Okay? All right, we're going to go ahead. I wanted to pause it and do it there because we're going to skip the checkpoints at the end here. We're going to do these last couple examples. Okay, one more thing I want you to write somewhere around here is very important, okay? So, identify congruent arcs. Determine whether the given arcs are congruent. Explain why or why not. So what I want you to write, maybe over here, you need 2 things to be true for these to be congruent arcs. You need congruent angles, and you need same or congruent circles. Okay, so box that somewhere off to the side. That's what we're talking about here. It says identify congruent arcs. Tell whether the given arcs are congruent. Explain why or why not. So arcs are going to be congruent if they're on, it's the same angle. So if these are both the same angle, and also if they're on the same or congruent circles. Okay. So looking at A. Yeah, maybe we'll do a couple examples at the end here, but we'll see. We'll probably do these all 3 together. Okay, so first of all, looking at arc BC and DE, are these angles the same? Are the angles congruent? They are. They're both 75, so that part's a check. We can do that to check there, okay? What about, are they on the same circle, or are they congruent circles? Yeah, do you see how these angles are both on the same circle right here? They share a circle. So we can say these arcs are going to be congruent because, yes, congruent angle, same circle. Okay, congruent angle, same circle. Now, B is going to give you an example of what I mean when this is not, when one of these is not true here, okay? So I kind of gave it away here, but I want to make sure you guys see this, okay? So for B, it says A, B, and CD. So we have A, B's right here, and then we have CD. CD is right here. Okay, are these arcs congruent? Well, are they the same angle? Yeah, they're both 80 degrees, but are they on the same circle or not? They are not. Do you guys see this circle inside here is smaller than the big circle on the outside? Right? So are those arcs going to be congruent? Is it going to take the same distance to go from here to here as it takes from here to here? No, it's not. Do you see how It's kind of like on a racetrack. You guys know, like on the track when you're. So here's a track, and then we have people starting right here and starting right here. We're doing that because it's a shorter distance to go on the inside of a track than to go on the outside of a track, right? Because this is going to be longer. So for B, CD is not going to be the same arc. It's actually going to be longer. If you were to straighten these out, CD would look like this, and AB would look like this, right? If you stretch out these arcs into straight lines, they're not going to be the same. So that's what I mean by it needs to be same circle or congruent circles for them to be the same. Okay, hopefully that makes sense. So this one's going to be no. I'm going to erase this right here. This one's going to be, let me fix that. This one's going to be no. It's the same angle, but not congruent circles. Same angle, but not congruent circles. CD is going to be longer because it's on the outside of a bigger circle. Okay? And then C is the last one. It says FG and HJ. Well, are these angles the same inside the central angles there? What are these? What's the symbol mean right here and right here? Yep, they're both 90, so this is going to be same or congruent angles. Sorry. They are congruent angles. Are these circles the same, though? Can you guys tell? Are these circles the same? They look like it, but there is something here that tells us that these are congruent circles. Do you guys see what it is? Do you guys see this tick mark here? If you remember back from the original notes, the beginning of the notes, it said that congruent circles have the same radius. So these tick marks means that these radii are going to be the same, which means these are going to be congruent circles. This is going to be yes, congruent angles, and congruent circles. So congruent circles need to have the same radius. It means it keeps them like at the same width, basically. Like over here, this radius and this radius are different, which means they're going to be different circles. Okay? All right, I think that's where we're going to stop for today. Let me just double check here. Yeah, I think we're good. All right, thank you guys for watching. Hopefully this makes sense, and I will look forward to hearing what you guys have questions on, and yeah, hope you guys have a good day. Thanks.